All right. So here we are on chapter 2, 2.1, which is power and radical functions. So the objective is that you'll be able to graph and analyze power functions. So the first thing, power functions in lesson 1.5, you studied several parent functions that can be classified as power functions. A power function is a function of the form f of x equals a times x to the nth power. Right, so as long as you have an x to the nth power, um, and n has to be a non-zero, because if it's zero, it's just going to be there's not going to be an x. It's going to be a constant. All right, and a power function is also a type of not monomial function. Monomial function is a function that can be written as f of x equals a or f of x equals a times x to the n. All right, so we have different shapes, and we have the first one. So they're going to look different on 4 cases. So if the n, that power, is even, then it's going to be a parabola. But if the a is positive, it's going to be a parabola that's going up, positive, smiley face. And if a is negative, frowny face, right? And it has the domains and range and all that stuff there. Okay. Just remember, if it's even, you get a parabola. And if the a is positive, it's smiling. If it's negative, it's a frowny face. Let's put this on the notes. All right. Now, the other two is if the power is odd. So if it's an odd number, it's going to get that one side is going up, the other side is going down. All right, kind of a look to it. Um, so yeah, and if the A is positive, then it's going to be going up as you go to the right. So as you go to the right, it's going up. Negative, as you go to the right, it's going down. That's the way to remember it. As you go to the right, positive is going up. As you go to the right, negative goes down. All right. And there you have the domain and range and all that stuff there. All right. And yeah, we're going to look at some examples. All right. So first one, graph and analyze each function, describe the domain, range, intercepts, and behavior, continuity, and where the function is increasing and decreasing. So let's look at numbers. We'll do 3 of these. We'll do 7 and then 8, and then we'll do number 16. All right. So first one we'll do is 7. Okay, so some things to note. You can plan out what it's going to look like. So you notice that the n is odd and your a is negative. So odd means it's going to be going like this, but then because it's negative, it's going to be, let's see if I could do it. It's going to be switched around, flipped around. It's going to be going down from left to right. All right. So let's look at it. Let's make our table. Now I'm going to put a y. It's the same as f of x. Okay. So we have 1, 2, 3, 4, 5. So I have 5 spaces here. I usually choose the numbers 0, -1, -2, and 1 and 2, just around that 0. You could do more. You could use bigger and smaller numbers if you'd like. Whatever is fine. And then the way to do that is you use your Desmos. Okay, use Desmos or whatever calculator you prefer. Right? And then you just plug those in. So y equals -1/2, and then times -2 to the 7th power. Right? And if you want to see how to do that, we have -1/2, put the cursor on the right, parentheses, -2, close parentheses, and then a to the b, all to the 7th power. And there we get 64. Is that correct? Wait, did I put a different number? Oh, what did I do before? Okay, well, there you go. 64. Wow, that was nice. Yeah, and then just keep changing it. Change this to 1, and I'll get 0.5. Ah, I miswrote it. Okay, yeah. And here, if you plug in 0, it's just going to give you 0. And then here, um, because we have an odd exponent, yeah, it's going to be the same except different signs. Okay, so it's the sign whatever what it is. So here, it's a negative, so it stays negative. And here, if we make it a positive, it's going to stay positive, and it changes the sign for this answer. So notice it's the same thing except negative. -0.5, and the same thing is going to happen with a 2. Don't believe me? Try it. See if it works. I think you'll be surprised. All right. And there you go. So we have that. And then you just plot the points. Yeah. So 0, 0, 1, -0.5, 2, -64, all the way down there. And then 1, -1, comma, +0.5, and 2, comma, +64. So it goes all the way up there. So there we go. Here we go. Here we go. Okay, that's it. That's what our graph looks like. And the domain is going to be the x values, right? So it goes all the way to the left, and it's going to go all the way to the right. Okay, how do you know? Because we have arrows there, right? Those arrows mean it's going to go on forever. Slowly to the left, but then still. This is all real numbers. The range are the y values, and notice that it covers all the y values. The lowest point is -infinity, the highest point is +infinity. It's all real numbers as well. Intercepts, it intercepts at x equals 0 and y equals 0. And behaviors, so f of x goes to +infinity, as x approaches negative infinity, and f of x goes all the way to the bottom, keeps going down to negative infinity as x approaches positive infinity as you go to the right. And continuity is continuous, right? There's no holes or anything. And then where is the function increasing and decreasing? So everywhere start from left to right, it keeps going down. So this one is decreasing everywhere. Everywhere. There you go. That's 7. Let's look at 8. All right, there you go. Let's look at number 8. Number 8, it says g of x equals negative 1/4 to the, times x to the 6th power. So here, here we're starting. All right, so there you just plug that into Desmos, just like last time, right? Y equals negative 1/4, parentheses, negative 2 to the 6th power. All right, and then if you do, you get negative, I did it already, negative 16, negative 0.25, 0, negative 0.25, and negative 16. Whoa, 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 whoa. So these are the same, negative, negative 16, negative, negative 0.25. The reason why is because it is an even n. All right, so that means we're going to get a parabola going up or parabola going down because our a is negative. That means we have parabola. Brownie face, right? So yeah, that's what's happening there. 0, we have 1, and negative 2.5, negative 1, negative 0.25, and negative 2 is all the way to 16. That one goes all the way off of the graph again. But we're used to it, aren't we? There we go. Okay, it's a very steep parabola. All right, and domain, as you can see, it always goes to the left, always goes to the right forever, and in between as well. So that one is all real numbers. But the range, the y values, the lowest point is negative infinity, but the highest point that it goes to is 0. All right, and the intercepts are x equals 0, y equals 0. Continuity is continuous. And here, as you go for the increasing and decreasing, as you start from the left and go to the right, notice that you're going up, so increasing from negative infinity from the very farthest left to, and it stops at 0. And then it goes back down. Ah, think of a roller coaster. From 0 to positive infinity. Just imagining a roller coaster going down forever. Oh, that's scary. All right, there you go. That's number 8. All right, now I did want to show you one where it is, what is it? What was I going to show you again? All right, the negative. And if you're wondering, what is that negative exponent mean? If you're wondering, what does that negative exponent mean? Remember, negative exponents is the same as 1 over x to that positive exponent. So when you have a negative exponent, you want to flip it. Okay, if it's on the top, it goes to the bottom. If it's on the bottom, then you're gonna bring it to the top. Okay, so you just put it in the other place, basically. Then make it positive. All right, so let's look at 16. All right, and if you want to try 15, feel free to. Yeah. All right, we're gonna do the same thing. 1, 2, 3, 4, 5. Okay, so we have -2, -1, 0, 1, and 2. All right, so our 0, because it is a negative here, we can't have a 0 for the x. Because that would mean that we have a 0 in the denominator, which we can't have. All right, so this one does not exist. All right, but the others just use Desmos. All right, so y equals -7/10 times -2 to the -8th power. And when you do that, I got -0.003. And when you plug in -1, you get -0.7. When you plug in the +1, because it is an even, right? Even, still going to be the same. -0.7. And plug in the +2. There you go. Then just plug in those points. So because it doesn't exist at 0, it's going to be an asymptote. Green asymptote. All right. So we just made that dotted line there. And I'm going to put -1, comma, oops, not there. -1, comma, -0.7, and then -2. It's going to be really close to 0, basically. All right. And you're probably thinking, whoa, what? Yeah, we can graph it from there. Here, 1 comma -0.7 and 2 comma -0.003. Try those out, see how it goes, and we are going to show you how to do it. So it looks like it's approaching 0, and then it goes down forever. Same thing. Wow. All right, and there we go. So the domain, it would be all real numbers, but then we have an asymptote here at 0, so it goes from negative infinity to 0, and then the union of 0 to positive infinity. The range is going to be, the lowest it goes is negative infinity. The highest that it goes is almost 0. Doesn't approach 0, but it goes there. And then in behavior, so on the left, f of x approaches 0 as x approaches negative infinity as it goes to the left, and f of x approaches 0 as x approaches positive infinity as it goes to the right. All right, intercepts, no intercepts. And behaviors. So on the left side, oh, I did the, I'm sorry, I did our in behaviors already, right there. Continuity, it's an infinite discontinuity. At x equals 0. And then from the very farthest left, it's does it go from left to right? Going down. That's from negative infinity to 0. But then, as you get from 0 to positive infinity, it keeps increasing, keeps going up. Slightly sometimes, but that's okay. And that's it. And that's it. So try it out, see how it goes. And then, ooh, we have 4 minutes left. Hmm. Okay. So I might talk about these tomorrow. It's actually the same thing. It's if you have a fraction in your for your power. Okay. If you do, remember here, same thing. If you do, remember x to the 1/5 is equal to the 5th root of x. Also, if you had x to the 2/3, that's going to be, so the bottom number, the denominator, is your n. That's the third root, the cube root of x, and then that, and the numerator stays with the x. Right, you don't need to put the 1, but just know that it's there. Okay, so radicals are a little different. Remember if we see invisible numbers, it's a 1. In this case, if you had 3/2, our n here would be 2, right? But we don't put a 2, we put nothing because that's the square root, right? So there's an invisible 2 there. Invisible 2. Then we have x cubed. So square root of x cubed, basically. All right. So keep that in mind. If you want to try 22, feel free to. All right, and we'll do 23 next time. Should I just do it now? No, let's do it next time.